we need to understand. We started the topic, this. We started right from here, and we understood the wash plates, and now we will be moving on to understanding the forward structure. I think we did not do that. First, tell me, are you comfortable with this pounding and slamming, or do you want me to talk on it again? Because I'm not doing that. Everything is written here, and if you have understood what they are, there won't be a problem.
Yes, sir.
Acha, theek hai. Then I will not touch upon that. Because uh, whenever you study about structures, you will not understand the importance of those different smaller structures if you are not familiar with the reason. The reasons are different types of loads and different types of behavior of the system. That is why uh, such arrangements are made. Like nowadays, you will notice uh, earlier the electric poles besides the road, they used to be simple concrete type, right?
Yes, sir.
Nowadays, you will see that they are being replaced by a steel frame kind of thing. Okay, so when you look at it, you will feel like okay, for some reason they are doing, but actual thing is, it is being done so that air can pass through. So even during a rough weather, those poles they will not, kind of fall down, which earlier used to happen. So always when we are jumping onto the design of a structure, pay attention to the reasons for such design. Every particular change that is made in a design or a structure is because of some reason. All the reasons are not very logical in nature. Some reasons are just how to say. Some reasons are more or less uh, coming from observation. In this ship construction, the advancements that we see, a lot many of them happened during the World War, and the advancements that happened, they did not happen because of logic or science. They happened because of observations. I mean, they used to make ships, for example, Hitler used to make the ships and he used to send it to suppose UK. But in the sub-zero temperatures of water, the ships used to break. Because there were no telephones, nobody used to know that okay, they have broken on their own. Later on, they understood just by seeing repeatedly that there is something called as brittle fracture. This ordinary steel, when it experiences sub-zero temperatures, it just cracks and fails. Okay, so the reason I'm saying this is we will be talking about four-peak arrangement, and in the four-peak arrangement, there will be some new types of structures, unusual kind of structures which we do not find in other parts of the ship. And it is very rare that you will get to see them because not everyone goes in there. Because you're nautical science students, you don't have to go into tanks and everything. So you have to know the reason, and only then you will be able to appreciate the structures and why they are placed in this manner. Okay. With that, I will move on. So now the most important criterias or the most important loads that influence the design of this four-peak arrangement. First one is panting. Second one is pounding, also called as slamming. Okay. So when we think of that, we have to protect the structure from these two types of forces. I mean, they are predominant in those regions. So, okay, let's not see this figure. This figure is slightly difficult to contemplate. We will see that in 3D first. We will understand, and then we will come back to 2D. Now, just to start the topic, panting means the in and out movement of the side shell. Okay, I have the plate, the plates will try to move in and move out. So to stop them, we have to fix them something. We have to kind of fix them so that they're not moving in and out. And pounding means the ship is kind of hitting the surface of water. So those bottom platings have to be stiffened in some manner and other things. Okay, let's see. Let's see what we can do. This will represent the forward end construction of the ship, how it is done. We have the collision bulkhead. In front of the collision bulkhead, we are taking the stem bar and we are keeping floors. The floors are normal, but here all the floors that will be used, they are solid floors. We have already discussed what they are. They do not have any openings in them. They are solid floors. And their spacing is also reduced compared to the other regions. Thereafter, we put the stem, we put the breast hooks, and then side shell is not important now. We will have the normal framings, just like we have in other places. But in these places, the spacing between the framings will also be reduced. Okay. We have put the chain locker compartment. We have put the panting stringers. Remember that now what I say that will be slightly confusing. Stringers is a name given to longitudinal frames. Okay. You will be seeing transverse frames usually this manner. We have seen this earlier. This looks bad. So these, this one, these frames, we have seen them. Okay. These are the normal transverse frames. But when frames are arranged in the longitudinal direction, that is fore and aft, just a minute. In this region, yeah, these ones. These are called as stringers. But just know this. The reason I will tell you why I'm reluctant to say that, because later on, I think we have seen already deck stringers. Deck stringer refers to a plating, a strake, which is connected to the side shell. Okay, that is a stringer plate. And the common notation of stringers means a longitudinal frame. And keeping this is not enough. We need to keep some connections between these so that our side shell does not go in. So basically here, the panting stringers, breast hooks, and these, okay, I think we have it. Yes, we have it. the panting beams, they are to take care of the panting loads. And down below, what we have done by keeping floors, solid floors close to each other, we have increased the thickness of the, not thickness, the increase the strength of the bottom shell plating. So now this structure is more resistant to pounding because of the positioning of floors close to each other. And the side shell, it cannot move in and out now much because we have our panting beams, the panting stringers, and also we have our breast hooks in place. Is it okay?
Yes, sir.
Okay. Now, this shows the wash plate that we discussed in the other class for minimizing the free surface effect. Okay. So this is how the structure looks like. To explain that better, we have this particular drawing. This book, this is given in, this diagram is from DJIS book. In this book, this diagram is given. We have our collision bulkhead right here. On the collision bulkhead, stiffeners have been shown. Connected to it is our chain locker compartment. We have the floors placed close to each other. We have the panting stringers, these. We have the panting beams, and in the forward, we will have the breast hooks. So, and we have the wash bulkhead. Now, if I go back to this particular plan, it will make more sense, little bit of more sense. Only watching it in 2D was difficult. Okay. इसमें कोई any question, any doubt? What is this? What is that type of questions? No? Any questions? Any confusion anywhere? If not, I will move on to the next one.
Yes, sir. It's clear.
Okay. ठीक है. We will move on then. This is okay. Acha, I did not talk about one thing. I wanted to talk about that at the end. That is the aft peak tank. Right here it was, yes. Actually, aft peak tank, it is not as much critical compared to the four-peak tank. The aft peak area is not subjected to unique kind of forces compared to forward bulkhead. I mean, there are some unique criteria that I will tell you, but it is not written here. So this region, in this, the aft peak tank which is shown is this one. Okay. This area faces one big problem. No, it does not face essentially, it may face. But to eliminate the problem, steps are taken in the design phase itself. What we do is uh, think of it this way. Uh, do you know what is cavitation of propellers?
Sorry, sir.
Cavitation of propellers.
No, sir.
No, sir.
Okay, okay. Okay, we will see that later on. Okay, so this tank, the positioning of this tank is such that it is close to the propeller working field, and propeller is running. It is kind of a fan which is moving. Uh, okay, I will not jump into the details, cavitation and everything, but just understand that because of the propeller working over there, what will happen is, what does the propeller do? The propeller is a fan like this. Essentially, the water is coming from forward. The propeller is kind of sucking that water and it is throwing
Yes,
it
sir.
back.
Yes, sir.
So, yes. So, because it is throwing it back, we are getting a reaction force and the ship is moving forward, isn't it? So,
Yes, sir.
now because it has to suck the water and throw back, the propeller needs some amount of proper clearance all around it. By all around it, I mean this particular clearance, and clearance down below. When we design a propeller, these three dimensions, also some people are considerate about this also. Not some people, we should be. Okay. These four clearances are simply named as ABCD. They do not have any specific names given to them. When you design a propeller, you have to give this parameters ABCD. What happens is, if these clearances are not sufficient, most critical is this one, and this one. If these three clearances are not sufficient, then what will happen is some unwanted and undesirable kind of vibrational forces will be transmitted onto the hull. And we don't want that kind of forces to be happening, because if you notice, this transom of the ship is kind of a overhanging beam. It's like a cantilever beam. It is much towards the aft. So because of that, we don't want these vibrational forces to be uh, transmitted. Okay, that is one big difficulty for this region. But to take care of that only, uh, the propellers are designed in a proper manner. But still, then uh, there is a phenomenon called as cavitation. This cavitation, I will tell you about this when we study about propellers. I don't know if they have this cavitation in your topic or not, but this is something that you will feel during your job. When cavitation occurs, you will you will realize the vibrations from your bridge also. So we will study about this, how it happens, how we can reduce it, and everything. Okay, so this aft peak tank is not that much special when compared to four-peak tank in construction point of view. It has the same normal things. Only thing that we do is we just keep the uh, transverse framing close by. Because this is an overhanging structure, we just keep the transverse frames close by, and that takes care of the strength. We don't add any new additional types of structures here. Okay.
Yes, sir.
Yes. And one more
Yes.
thing, this particular region is also sensitive because we have our propeller shaft going out of the hull. So because of that, locking arrangement, sealing arrangement is critical, but that topic is not related to our tanks. So we will leave that for now. I think we have these topics. We will discuss them at appropriate time. Okay. So let's see what else we have. Bulbous bow. Bulbous bow. Okay. Bulbous bow, as the name is bulbous bow, you can probably say that it's a type of bow. Um, you all must have seen bulbous bow.
Yes, sir.
Suppose this
Yes.
was the bow portion. What is done is they add something like this, right? So that becomes the bulbous bow. Do you know why we have a bulbous bow? What is the use of it?
So that the ship can move through the water and cut the water.
I know. Anyone, any other answer? Okay, let me ask you.
So it
I mean,
reduces fluid friction, drag.
okay, yes, this was a very nice answer. Very good. Now, the first answer that we got, did you read that somewhere, or did you just have a feeling by looking at it that it helps cut through water?
No, sir, not read somewhere, but have seen videos and online.
Okay, yes. No, that is a very logical way of thinking. But actually, what happens is the second answer was more precise, that it reduces the friction or drag. I will just tell you how. That how is not written here. Just understand. When the ship moves through water, first of all, know that there are different types of bow. Bulbous bow is just one of them. Nowadays, there are X bow, many various types of experiments are being done. Okay. And bulbous bow is suitable only at lower ship speeds. Okay. For some ships which move at lower speeds, by lower speeds, I'm referring to a range up to 15 knots. Beyond that, bulbous bow is not effective. The reason why bulbous bow is added is any new structure that we have added. Now, this particular thing that we have added is definitely not from strength point of view. We can understand that by looking at it because it is outside the hull completely. So, the other reason that it may have been added is to save some money. When the ship moves in water, it experiences some kind of resistance from water because of viscosity or whatever the reason be. Now, that resistance that the ship experiences is because of a number of parameters. Okay. And remember, one particular One particular parameter that adds to the or one particular type of resistance is called as wave making resistance. In the normal water, when the water was still, the waves were not formed. But when the ship moves through them, suddenly waves are formed, right? And the waves are moving away also. So where did they get that energy to move from one point to another? I- थोड़ा confusing लगा क्या statement, was it?
No, sir.
So, okay. So this still water, it suddenly gained some energy to be able to move. It derived this energy from the ship. So this energy that was lost by the ship, that was because the wave gained it. So if we can form this bulbous bow, what it does is it stays ahead of the ship. Okay, it stays ahead and it stays underwater. So it does not create a lot of waves, but underwater it generates a pattern, it generates a kind of flow that minimizes the making of these waves. Is it clear?
Yes, sir.
Yes. So the positioning of bulbous bow forward of the ship, it essentially reduces the wave making resistance of the ship, which is why they are added. Okay. So this is not written here. You don't have to write it anywhere, but know that because uh, usually in nautical science exams, I don't see that why wale questions. They are most of how this is done, how that is done. But you should understand concepts when we are studying something. You should know the basic idea behind it. So this bulbous bow, there are other types of bow also. Nowadays, this type of bow is also being used a lot, called as X bow. You can read about them some days later. And interesting thing is this X bow, it was designed by a student. And that student was a bachelor degree student somewhere in Denmark or Norway somewhere. That student has his project, I think. He designed a new type of bow just as experiment, and that was adopted world over. So a student at your age, he developed this X bow kind of structure. So the collision bulkhead, similar things. Panting stages and beams will be there. Our longitudinal frames or stringers. These longitudinal frames are only called as stringers, but in different places, the word stringer can have a different meaning. Like we have deck stringer or stringer plate. Remember these two differences. Many a times people will ask you questions just to understand whether you know the different connotations or not. Okay, that is what people they want to see, whether you have heard of the word stranger in different context or not. Always pay attention to these things. And that's it. Actually, the bow portion, the forward, the tip of the bow, it is slightly extra stiffened. This extra stiffening that is given here is from collision point of view. You will notice that mm, here I do not have any pictures, but when there is a ship like this, suppose the water line is still this, okay? So you will see that on the hull there will be a marking like this, and it will be written some maybe some feet or some meters. Suppose 2 meters will be written here. Have any one of you seen such a marking?
Yes, sir.
Yes, sir.
Draft marks.
No, draft marks are there, but the marking which is done along with this symbol, with this particular green symbol. Have you seen?
No, sir.
Acha. Okay, this is also there besides the draft marking. This marking, whenever it is present, it tells the other people this is not important for the ship crew. It is important for other tugboats and smaller boats. It marks that there is a bulbous bow, and that bulbous bow is 2 meters ahead from this particular point. Because it is submerged in water, people may not know that it is there. And if a small boat comes to that region, because of the draft of that smaller boat, it may hit the bulbous bow. Is it understandable why we have that marking?
Yes, sir.
Yes. So this kind of a marking is there. Let me see if I have a picture of it. I think I have. If I have, I can show you that right now. Just a minute. Okay. If I get it within 1 minute, I will show you. Otherwise, I will show you some other day. This one, this one, not this one. Mm, कहाँ गया? This one is perfect. ठीक है. Yes, I got one. देखिए. Let me send this to the laptop, and there itself I will show you. Yeah, yeah, yeah. Maybe this also. ठीक है. Okay, I got them. Yes.
Yes, sir.
Okay. So here, what you are seeing, this particular marking, can you see?
Yes, sir.
Yes, sir.
Now, this represents the presence of the bulbous bow some meters forward from this particular region, because this color change, it represents the design water line. The ship will be floating at this particular water line. So other smaller boats, they need to know that there is something present underwater at this particular position. Okay.
Yes, sir.
Yes, that's it. So just a moment, I will just resume back. Okay, so this is about bulbous bow. This is a model showing the structure of the bulbous bow. Similarly for stern also, but this is not part of your syllabus. That's not. But still, to say you, here there are not many unique structures other than the transom frames. Again, we are talking only about transom here, but transom is only a particular type of stern. There are other types of sterns as well. There are cruiser stern and separate things which we will see on some other day. But the most popularly used stern as of now is transom stern. I mean, container ships, they love it. Bulk carriers, they love it. So transom stern is most widely used. So that being said, most of the structures are same. We have our frames and longitudinal girders. These are the side girders actually. And we have transom frames which are connected by some brackets. That's it. There is no other difference. And this is not in the syllabus also, it is just added. The reason that transom stern is so much widely used is because of this particular thing. It provides us a large deck area. Because of its shape, the large deck area that we get because of it, and also the large volume that we get beneath the main deck is important. And for that particular reason, transom stern is widely used. Do you know what a catamaran is?
No, sir.
Okay. देखिए, I'll just give you the logic of this area thing. Suppose I have usually the vessels that we look at or we are studying, they are monohulls. That means I have a ship. There is only one hull, isn't it?
Yes, sir.
Right? But we have ships which are more than one hulls. Like they will be of this nature, this is one ship and they will be connected. Okay. So two hulls are submerged in the water. And as a result, the deck area that you get is kind of tremendous. These kind of vessels are not cargo ships, but just understand that when we want more deck area, we can bring in various different types of design changes. Transom stern is one of them. And these are called as catamarans or twin hull vessels. Okay.
Okay, sir.
Yes. Now the same thing. This is a transom, side wing tanks and bilges. Side wing tanks and bilges. We have time. You are ready with your attendance data now? I do not have to spend time on it.
Yes, sir.
Okay, then we will continue. So, wing tanks. Wing tanks are important and are used for various reasons. When we discussed about double hull, I think we discussed why double hull is required for different types of ships. Am I right?
Yes, sir.
Yes. Similarly, wing tanks are also not mandatory, but may be essential. In some cases, it is mandatory, like for oil tankers nowadays. They need to have wing tanks. But for other types of vessels, it is not. So, why do we need them? First of all, let's think. Think of a bulk carrier. In a bulk carrier, wing tanks are not that much important. Okay, let me tell you why and how wing tanks can be useful to us. By now, have you studied the position of center of gravity, stability? Have you started that?
No, sir.
No, no. Okay. देखिए, do you know what is center of gravity of a body?
Yes, sir.
Okay. So center of gravity of a body is connected to the mass distribution in the body. Am I right?
Yes, sir.
Now, suppose I have a block. Okay. In this block, what I do is I have different racks. Okay. So I can assign my weights at different levels. If I put all the weights here down below, my CG will be somewhere here, maybe close to it. If I take the same mass, to upper level, my CG will be slightly raised. Is that right?
Yes, sir.
Okay. If that is right, so from here you can understand that for different loading conditions. No, let's directly jump onto the topic. When the ship is returning empty, you will be taking ballast, right? So this ballast, when it is put in the double bottom, think of it this way. When you are putting ballast in the double bottom, in that case, the mass is concentrated at a lower level, right?
Yes, sir.
So because of that, the center of gravity of the ship will be lower. Okay. And because it is lower, have you studied what is metacenter yet?
No, sir.
Yes or no? क्या बोला आपने?
No, sir.
No ना? अच्छा ठीक है. ठीक है. Let me give you an example. When you were young, you played with those dolls, right? Which used to come in the mela. The doll will be like this. It will be written here, hit me. You hit it, it will fall down and it will stand up. Have you seen that?
Yes, sir.
Now
Yes,
in those toys, what was special? How were they made? You will notice that they will have some mass here, right?
Yes, sir. Base was heavy.
Yes, base was heavy. Some sand band thing they will put it there, and as a result, you hit it, it will come back. Basically, in case of a ship, something like that happens. We will not jump onto it because the teacher who is going to teach you stability, they will approach it in their own manner. When we have ballast in the double bottom only, the center of gravity of the ship reduces. Reduces means it goes down. It reduces in height. Okay. It goes down. And when the center of gravity of the body is down, there is something called as a metacenter. Okay. The height between the center of gravity and metacenter is called as stability or measure of stability. Okay. So the ship becomes more stable. But when the ship is more stable, think of it this way. This little toy that we talked about, imagine you are that toy. someone hits you, you fall down and somebody lifts you up in that same speed, the speed with which the toy comes back. Will you like that? Or if you fall down and you slowly wake up, you will like that?
So the latter.
That slow one, right?
Yes,
So,
sir.
in short, if the ship's center of gravity is down below, then the ship is more stable. So, when the vessel rolls to a particular angle, it will very quickly come back to the normal position. Okay, that particular situation is called as a stiff ship. Okay, understood? और थोड़ा doubt रहा? Did you understand the stiff ship concept? Did you? Are we connected?
Yes, sir.
Acha, this much is understood, right?
Yes, sir.
Okay. So to prevent this from happening, imagine if we can flood the wing tanks. Now what we are happening is the mass distribution, which was otherwise very much focused in the bottom, now we have distributed some mass till the top. So as a result, our center of gravity will not be that much down below. Is it clear?
Yes, sir.
Yes, sir.
So that helps us in preventing this stiff ship condition. That means if the center of gravity is little higher, your stability is little lower. The motions of the ship will be more comfortable for the crew members. From here, you can deduce that even in case of stability also, we do not want the ship to be very stable. There has to be an optimum amount of stability that the vessel needs. If it is very stable, it becomes uncomfortable for the crew. If it is less stable, it is dangerous for the crew. Okay, understood? Understood now?
Yes, sir.
Okay, then we will stop here. Please give me the attendance data.
064 is absent.
064. आपका डिवीजन कौन सा है? 2. Division 2 and today it is 4th of March. 04 ना? कौन सा बोला आपने?
064.
064. Okay, he was absent the previous class also. Only that guy? Anyone else?
No, sir.
But actually, तो three or 2 people are absent. One has
Actually,
left.
one just logged out 041. He was there in the entire class. He just logged out.
अच्छा, okay, ठीक है. I will save this now.
Yes, sir.
Okay. If no